Hi, everyone. Welcome to this presentation. This is Molecula and Oracle Cloud Native Services. My name is Akshay. I work in developer and product marketing at Oracle Cloud. Been with Oracle Cloud for just over a year now. Been with cloud computing for over 4 years. I'm very pleased here to be joined by H.O., who's the CEO of Molecula. H.O., could you introduce yourself?
Yep, so thank you all for having me here today. I'm a addicted entrepreneur. I'm on my 8th company, and it's amazing every company, how many advances there are in the world, and it's pretty exciting to be living what's happening at OCI right now, and look forward to talking about that a little bit more.
Yeah, H.O. has a pretty interesting history with his entrepreneurial activity, so you should talk to him if you get a chance. As is customary, I'm going to be talking about Oracle products, particularly there may be some statements forward-looking, so please note the safe harbor statement. We hope to keep you entertained in this presentation, and hope to have some interaction as well. First, I'll go through Cloud Native, and then Oracle's products for Cloud Native services. We'll then go through a Q&A with Molecula, hopefully have a good dialogue with H.O. And then there'll be a quick demo. I will walk you through 2 of the services from Oracle Cloud. These would be the container engine for Kubernetes, which is an orchestration service for Kubernetes, and also our Oracle Cloud Infrastructure Registry, which is the Docker registry. So Cloud Native, let's just start by kind of understanding what Cloud Native is. Many people refer to Cloud Native as an application that is born in the cloud. So these applications are typically designed for architectures that use infrastructure as a service, platform as a service. These things are available as a utility, and you develop your applications assuming these services as a utility available to you. Now, I want to extend that a little bit more. So cloud native applications can also be highly dynamic, highly scalable applications. They can extend across different environments, public cloud environments, private cloud environments, combinations of them. So hybrid cloud, multi-clouds as well. So when you think about it from that perspective, there are different characteristics that cloud native can embody, right? So these things could be things like you might be using containers in your IT infrastructure. So containers are an example of encapsulating what you call microservices. Services that are contained. Microservices, number of these microservices will make up your application and provide that additional dynamic scalability that you require. With a microservice, you can scale up your microservices in a more granular way as your application needs grow. Addition to that, you can have things like infrastructure as code. Infrastructure as code basically allows you to provision vast amounts of infrastructure programmatically, reduces configuration errors, makes your DevOps more efficient. Could also have things like streaming. So streaming is about, again, reducing the ops burden. So when you have tens of thousands of IoT devices. You have lots of data coming in from various sources. You want an efficient way to buffer all this data and then pipe it through to something like an autonomous data warehouse, a data warehouse. That is the data warehouse part from Oracle Cloud. Or you want to use something like object storage and do some kind of processing on that object storage. Right, so streaming helps you with aggregating all that data, buffering it if you need to, and processing it. Functions is another example. Developers are not interested in provisioning infrastructure, provisioning the platform, as you all know. So what we want is to just what developers want is to just provide the code, and have the infrastructure and the underlying platform provided to them. So these are some of the different characteristics that you can see with cloud native, right? So I want to just take a quick poll here. Maybe just by show of hands, does anyone recognize all of these icons over here? Any non-Oracle? So the first one is, maybe you can just blurt it out. Docker, yes. And the second? Kubernetes, yeah. Okay. Fourth one is FN. So the third one is Terraform. It is the engine that it is an open source engine that we have adopted for infrastructure as code. So using Terraform-based infrastructure as code, you can provision infrastructure in Oracle Cloud and also other similar cloud environments. So it's an open standard that we've adopted. The fourth one is the FN project. So I have some goodies. I have some extra T-shirts. So hand them to you after the presentation. Cool. So in terms of how cloud native is used, as I mentioned before, it's used to give you these scalable applications. These applications can be decomposed into microservices, which can individually be scaled up, giving you that additional scalability. Some of these fast-growing unicorn companies, for example, have adopted cloud native to scale their applications into new global regions, for example, right? So that is one way. So you can also decompose your large monolithic application into microservices for this reason. Provides better scalability, better resource utilization. If you are starting out maybe as a startup like HO, maybe you want to build your application ground up with microservices, right? You don't want to build a monolithic application. You can start from the ground up building microservices. That's another way it can get used. Maybe you're not breaking down monoliths to microservices. Maybe you're just building right out microservices because that is a better architectural pattern for you. Addition to that, I talked about having these applications in a cloud environment, in a hybrid cloud, multi-cloud kind of environment, an open environment, right? So cloud native is used to move applications between a developer's laptop. You develop on your laptop, you push that to maybe a container engine in the public cloud, maybe it's the Oracle Cloud, and then you run it there just as you would run it in your laptop because it contains the application and its dependencies. So it's not going to fail in production. Finally, the last one is about using serverless. So as I mentioned before, serverless talks, it's not that no servers are being used, it's just that no servers are being used from your end. Cloud native provides the ability for you to execute containers based on code that you provide. So you just provide the code. Cloud providers such as Oracle will take care of executing that code in containers for you. So you don't even need to build your containers in this particular architectural pattern. So again, quick question to the audience. So cloud native, we talked about containers. These provide that ability to break up your application into microservices, right? And when you have microservices, how you can have multiple people work on that application simultaneously. So you don't, and releases will be faster, they will be more frequent. Infrastructure as code allows your DevOps environment to be more agile. You're going to be deploying infrastructure with code. If you're provisioning 100 servers, you're not going to be doing it manually. You're not going to be prone to manual errors. You're going to be doing it using code, a few lines of code. So same thing with streaming, better operations, better scalability, especially when you have a wide array of data sources. So like keeping these kinds of things in mind, maybe somebody can tell me, how much more efficiency do you think cloud native can give you? Is it 2x compared to a non-cloud native environment? Is it 3x? Anyone at all? 2x, 3x, 4x. It's actually more than even that. So, no, it's way more. More than that even. So the correct answer is actually it can provide up to 13x. A DevOps environment with cloud-native technologies such as containers, infrastructure as code, streaming, these functions can provide you 13x more efficiency, right? So this is quite significant. This is not, you're going to be 13 times more efficient. So obviously, I want to just spend a few minutes taking you through Oracle services for cloud native. So of course, we have services for application development and operations. So these would be your containers and functions, and then infrastructure as code services. We also have services for observability and messaging to take care of the management aspect of deploying your applications, your infrastructure. And all of this is built on Oracle Cloud Infrastructure, which is an enterprise-grade platform. So dig in a little bit deeper into the application development and operations. We have Container Engine for Kubernetes. This is the orchestration system to run your containers in production, right? So you don't want to be running your containers in production on your developer laptop. You want to have a highly available system for that. You can also use the registry to have geographically distributed container images, store and share your container images with the registry, and it's completely interoperable, of course, with the Container Engine. I'll show you a demo using these two services later. Container Pipelines allows you to build, test, and deploy your application. So you can build and test your application with Container Pipelines, deploy it to something like Kubernetes after that. So these three services work together. Resource Manager is a service for infrastructure as code. Provision infrastructure programmatically. You can eliminate a lot of manual steps. Functions, as I mentioned before, is about making the life of the developer easier. You just provide the code that needs to be run based on some events. And these are typically very short-lived, right? In observability and messaging, we have services for telemetry. So these are things like monitoring and notifications. So when you want to view metrics or when you want to get alerted on your cell phone. Streaming for messaging, so real-time data that's coming in from numerous devices. You can have that streamed to data sinks such as a data warehouse or object storage. Events, these basically allow you to trigger things like functions, also streams, and also notifications. So a way to think about events is, for example, maybe you have your compute node at high utilization, 90% utilization, and you want to set up events so that you get notified on your cell phone. So you would use the event service to do that for you. The LA boxes indicate that they are in limited availability. And if you want to get access to the limited availability service, you can talk to me or go to oracle.com/cloud-native. So real quick, I want to walk you through a couple of use cases. So this is a containers use case, how containers can get used in the real world, right? So on your bottom right there, what you see is an application. This is a Java application based off of WebLogic server, which I'll just refer to as WebLogic. And it uses a data store, such as Oracle database. And this WebLogic application and its database can provide something like a sales portal or a marketing portal that you use in your company internally. So what Oracle allows you to do is, it allows you the capability to lift and shift this application. So you can containerize the WebLogic to a Docker file. You can then use a tool such as Container Pipelines to build and test this application, push it to a registry, such as the Cloud Infrastructure Registry. And then you can use Container Engine for Kubernetes, which is your production-grade container orchestration system, to pull that to pull that web logic, both the application and the server, as container images. In addition to that, we also provide, as open source, the Oracle WebLogic operator. So the WebLogic operator is needed for you to easily manage your WebLogic application. So along with the WebLogic operator and your WebLogic containerized application, you can now deploy it into Kubernetes. And if you migrate your data store to something like autonomous transaction processing, you have your application now working in the cloud. Yeah.
I'm not quite familiar with Docker versus Kubernetes. So, I mean, when you're containerizing the WebLogic as a Docker, why do you still need Kubernetes on the other side?
It's a good question. You need Kubernetes because Kubernetes provides you the high availability. So you can run Docker even on your laptop. But what you need is a highly available system to provide that. Maybe you want that application to be distributed across different availability domains. You want to provide more scalability for that application, uptime, things along that nature. So it's an orchestration system. Yeah, so that's why.
On your local laptop, you can still run Docker?
Yeah, of course. Okay. I mean, so to keep it simple, yes, right? So you want to have a production-grade orchestration system to run it for your LOB or enterprise. Okay, so the second one is infrastructure as code. This is slightly different. This is more of a DevOps use case. And what you're doing is you basically put yourself in the role of a DevOps engineer. You want to programmatically create infrastructure code. So in this case, the DevOps engineer has a web server and a database, and then some associated infrastructure that he or she wants to provision, compute, storage, security, things along that nature. The engineer would typically deploy to a staging environment, fix issues in staging as they arise. Maybe you want to adjust your security policies. Maybe you want to adjust the shapes of your compute, shapes or sizes. Once you have a working configuration file, you now have a configuration file that can be reused as many times as you want, right? So that is the infrastructure as code. Streaming is also slightly different, so it requires a little bit of a shift from the infrastructure as code. In this case, what we are doing is we are collecting. Imagine you get thousands of events from your websites, from your mobile apps, from your IoT devices. And these events need some kind of a way to be buffered, right? So streaming provides that kind of real-time buffering of the data and then piping them out through something like object storage, autonomous data warehouse, so that you can do some long-term analytics or take some action in the short term as well. So you can run things like Apache Spark jobs. You can use autonomous data warehouse, things along that nature. Finally, monitoring, as the name implies, is about getting telemetry. It's about better observability of your data. So you can use Oracle Cloud Infrastructure Monitoring, Metrics Explorer to view your data in real time. You can use the notification service to get real-time alerts on your cell phone. We also recently launched in open source the data source for Grafana, which Grafana is a popular visualization tool that is open source as well. So you can use Grafana to view Oracle Cloud Infrastructure resources in a Grafana dashboard. Our APIs and SDKs are open. They're available to you so that you can use other solutions. These include like the Oracle Management Cloud and Prometheus and other tools. I should point out that Oracle Management Cloud provides you some additional capabilities beyond Oracle Cloud Infrastructure Monitoring. So these are things like security, logging, application performance monitoring, APM, and so on. So it's another tool that you can consider for cloud native if you want. I now want to pass it over to HO so that we can have more dialogue, maybe some Q&A. So HO, go ahead.
Okay, so I'm going to start with an example before we dive into what we do. I have two examples I can talk about today. I think I'm going to focus on the financial services example. We're a data virtualization company, and our objective is to help companies make their data AI ready. We see a lot of companies trying to do AI, and in our estimation, they do what we call is slow AI. So I'm going to talk about what it looks like when you do fast AI. So in financial services in general, there's a lot of bad guys out there, right? You've got good guys, bad guys, and then you actually have some people in the middle who sometimes can be a pain. And we'll talk specifically about this particular customer. They do the front-end banking for small and medium banks in the United States. About 10% of banking logins go through Q2. So that traffic can be good actors checking their balance. It can be bad actors trying to steal your money. Or it can be aggregators that are just trying to go after your data. So if you ever logged into something like mint.com, they're trying to get bank balances, and they do it all day, every day, unpredictably. So customers like Q2 have to be way over provisioned to be able to handle the spikes of their own usage and the spikes from these aggregators and bad guys. So today, customers like Q2 will do what we call is slow AI. They'll look at all the historical data, data sciences team will come in and train models on it, build signatures and deploy those signatures to try to stop the aggregators or the bad guys. That process at best can take 4 to 6 months to go from training models to scaling and putting those models in production. Well, guess what? The aggregators and the bad guys are changing the way they do things constantly. So by the time those signatures go up to the front ends, they no longer are as effective as they could be. So we have come in and said, hey, let's join all of the real-time data that's streaming in from those logins. Let's join all of the historical data, and let's apply those models in production as it's happening so that we can push those signatures out to the front end and stop the bad actors as it's happening. And so we call that fast AI. And we'll talk throughout the presentation of sort of what the difference is. But then I'll step back a little bit and sort of explain why I'm here today, why we're here. About 6 months ago, we decided that we were going to move our managed service to Oracle. Through my presentation and through some of the QA, we're going to talk about the decision making on why. I think overwhelmingly at the highest level, we wanted to focus on innovation and not having to worry about our infrastructure. It's a lot more nuanced than that, so we're going to hopefully unpack some of that as we go through some questions in just a little bit. And then just at a high level, I wanted to explain how we work inside of OCI. So on sort of both sides of our product, on one end, you've got data sources, and on the other end, you've got virtualized views. So we can connect inside of the Oracle platform to things like Oracle Streaming Service, a Kafka service. We have an integration with Golden Gate. Those are all data sources for us that we ingest into this virtualization platform. And on the other end, we make it AI ready, meaning we make it so that you can have ultra high concurrency. You can load your models and train them on that data without having to go to IT. You can then put those models in production on that data without having to go to IT. So it's really a way to sort of make peace between data engineering and data science when you get this platform in place, because otherwise you're doing slow AI. You're going through information requests, IT's outputting an OLAP cube, they're shipping it over, you're training models, you try to put those models in production, and then when those models go in production, they don't really work because they were never trained on the production data set. So we are really trying to short circuit that process. So why don't we jump into some of the Q&A?
Yeah, sure. Great intro on the fast AI and slow AI. So in terms of, what is the problem you're looking to solve? What are you seeing with Q2 and?
I think at the highest level, there's no question, I'm sure everybody in this room will agree, that AI is going to be a very important part of our future. So every industry, every vertical is experiencing productivity erosion, margins are becoming more thin, and ultimately we are firmly entrenched in the idea that the human-machine partnership is what's going to drive a lot of these productivity sort of recovery that needs to happen out in the market. However, we're in the process of experiencing what I call as an AI crash, right? And all of the innovation cycles of technology, you have sort of this hype cycle, and I think we're at the peak of the AI hype cycle. If you walk into a room of engineers and you even say the word AI, they react very negatively. There's so many definitions of AI. And so, in all of the data that we've looked at, we believe that data preparedness is the #1 problem in AI adoption. And so we're focused on helping make better decisions by helping make your data more AI ready. We do it through a technology that we invented called Pilosa, which allows you to create these virtualized views that are exponentially smaller, exponentially faster than the underlying data, and perfectly suited for executing on AI strategies. So that's the problem that we're seeking to solve.
So, in going about getting these virtualized views and all that, I'm sure you evaluated other clouds. So why did you choose Oracle Cloud? And
it's a great question. When we first started, launching some of our products inside of OCI, we just noticed that it was, it felt stronger, more robust, it felt faster, but that wasn't enough to make a business decision on. We knew we couldn't work in multiple clouds based on the type of business that we were creating. So we actually paused. We're still a very small company. We're about 15 people. We paused the entire company and did an incredibly deep benchmark. So we did about a 1,500-point benchmark on OCI compared to AWS, to Google, and we position our product on a cost per mega query basis. And across the board, we could not believe that OCI was substantially more cost effective for us on a cost performance basis. That's just one of the pieces of the puzzle, but it was certainly a very important piece of the puzzle and a great surprise to us.
Okay, so cost performance was a huge factor.
Huge.
So, regarding the cloud native services, I know you talked about streaming your data. What are these cloud native services from Oracle Cloud that you're using?
Yeah, so I think there's a couple of constructs on why we decided on OCI. We just talked about cost performance. I think agility is a second one. So from the very beginning, we were pleasantly surprised that Terraform was natively supported as part of Resource Manager. So infrastructure as a code is an amazing thing, and we'd already made some investments in Terraform, and all of our technology worked out of the gate. However, we knew we needed a deeper bench, so starting to move to the Kubernetes, the service, the OKE service has been a big part of what we're doing. And then more importantly, our ability to integrate with Oracle customers was a big piece of the puzzle as well. So some of the streaming services for monitoring and managing services, but also for moving data between and amongst services was important for us.
Okay, got it. So just to clarify, the Oracle service for Terraform, the managed service for Terraform is the Resource Manager service that I spoke about before.
Yeah.
So you touched on a little bit of this already in terms of the major benefits. That was the cost performance. Do you elaborate a little bit more on anything else as well?
Yep, so I sort of break it up in a couple of areas. We've talked about two, sort of that benchmarking performance, that's one. We talked about agility, so the cloud native piece. One of the biggest was peace of mind. So SLAs and OCI were substantially better than the SLAs that we were finding in the other clouds. And as you saw, we're running some pretty mission critical applications. We didn't talk about the healthcare one, but we're building AI co-pilots that are helping paramedics make decisions on the way to the hospital. So we certainly want to be in an environment that is as robust as it can be for us to deliver on our service. And then overall, we talked about cost performance with the benchmarks, but I would say in general, we did a 3-year sort of total cost of ownership study, and we estimated that because of all of these factors we just talked about, OCI was going to cost us about 50% of what it would have cost us to go anywhere else.
Got it. Any other pleasant surprises?
I think I'm allowed to say this on the record. Oracle did a blog post on us a couple of months back, and I was quoted on this. But when we started working with Oracle, we really literally thought we were about to go work with the evil empire. And we have been so unbelievably pleasantly surprised about how open everybody is, how hungry they are to sort of get ahead of everyone else in a pleasant way. But most importantly, really with the customer's best sort of success in mind. So when we go partner on deals, it is really amazing to see how the customer success is number one. So we were very surprised about sort of the culture that we found underneath what we thought we were going to find.
So spoke about you work in with Oracle on deals and things along that nature. What more can you do for your customers given the performance that you can get with Oracle Cloud and the services that are available to you?
I think one thing that is forgotten in this whole conversation about cloud is that a lot of the data is still sitting behind the firewall. And it's really difficult to move that data. People have invested in massive amounts of infrastructure, and moving to the cloud is a big decision because then you have to make more copies of all of that data, or you have to go through jurisdictional or political or technical constraints to move that data. So we've really been excited to learn more about Fast Connect and some of the services that Oracle has there. We really do believe that the next phase of cloud is going to be about hybrid cloud. And we think Oracle's really well positioned on the hybrid cloud side, especially with Fast Connect. And so we believe that data should stay where it's jurisdictionally, politically, and technically most optimized, but decisions need to be made where they're most cost effective and most efficient. And so I think that interrelationship between on-prem and cloud is something that's exciting for us.
Okay. I'm sure you had worries about going to the cloud and using Oracle. What worried you the most?
I think we talked about the evil empire, so I might as well keep adding my list of assumptions that I made ahead of time. But I think I also assumed that it would be a slow-moving company and that getting any kind of deal done wouldn't happen overnight. But we're really surprised about the agility. When there's a deal to get done, it happens. When there's value to be created, it happens. And along those lines, back to the performance thing, we were very worried, and we've been pleasantly surprised. The transactions per second, the throughput, the capabilities that we need to do these applications are not for the faint of heart. And so we've been really happy that those worries have put to rest from a sort of a performance standpoint.
Okay. So yeah, tell us more about the future. What's next for you guys?
So the next few days are actually really big for us. We launched this company 2 years ago, and we actually launched it under another name. The technology that we invented that solves this problem is called Pilosa. So the company was called Pilosa. The company's getting renamed, the new website, the press releases, the launch is happening on Thursday. So we're very excited to start to commercialize Molecula and to continue our partnership with Oracle. So.
All right. Congrats.
Thanks.
Congrats, Ichu. So I want to take you through a quick demo of these services. So it wouldn't be complete otherwise, especially at an event like Code. So in this particular demo, I'm going to, let me try to switch out of the PowerPoint. Okay, so I don't think. Okay, great. So can you guys read this at the back? Okay, cool. So this demo, we are going to show you Kubernetes and Docker. And what I want to do is first start off, maybe instead of going to the CLI, start off with the sorry. Start with the browser first and then go to the CLI after. Okay, so okay, don't know Wi-Fi access. Give me 1 second.
Demo demons happen.
appears to be fine. Sorry for the delay. Oracle Cloud. Trying to search for the, unfortunately, it seems as though I don't have the login correct. What is the login? Does any? Yep. Yeah, let me do that then. Thank you. Yep, there we go. Great. Okay, this is odd because my Wi-Fi is working, and yet my Okay, so I think there is some kind of an issue with the demo, but I do have a recorded demo for you. I apologize for this. Not sure how this. My apologies for this.
I'm having problems with the Wi-Fi. If it makes you feel better.
Okay. So. Let me open this up and show you a recorded demo as this was our backup option, which I hoped not to get to. So this is a demo of Kubernetes, Oracle Container Engine for Kubernetes and Cloud Infrastructure Registry.
Hi, this is Mike Brown. Today I want to show you some of the developer services that are available today within Oracle Cloud Infrastructure. I've logged into the OCI console here. On the left nav, you'll notice a menu. If I drop down the menu to developer services, I see two managed services, one for a Docker registry and one for a managed Kubernetes service. Let's quickly look at the Docker registry. Clicking on OCIR, which stands for Oracle Cloud Infrastructure Registry, I see the registry here with a number of repositories and images. I can quickly look and see the details of any of these by clicking on the particular image. Here I see a Hello Earth image with a metadata about the image and information about who pushed it and how long ago. You get full visibility to the layers, any of the metadata associated with the image. Now if I go over to clusters, I'll show you how easy it is to create a managed Kubernetes cluster in OKE. I've selected the clusters page. I'm going to create a new cluster. It's automatically naming it. It's automatically selecting the Kubernetes version. I'm going to use the quick create. I'm going to take all the defaults for the compute shape that I'm using, VMs. Bare metal is also available. If I come down, I hit create. The cluster creates automatically for me, creating all the associated VCN needed, and even a node pool. So everything is getting created now. As you can see, the cluster's creating, and let's watch as it brings up 3 VMs or worker nodes in the clusters that is spread over 3 availability domains for high availability. I can see now my cluster is active and that the node pool is starting to create. Okay, I see my node pool is active, all 3 worker nodes within the node pool, which is configured in a high availability fashion, is up and running. I now can go and access the cluster by using the kubeconfig that's available right here. Just as simple as that, I've created a cluster and can immediately begin using it. Thank you very much.
So that was a demo of Container Engine for Kubernetes and the Cloud Infrastructure Registry. So in terms of what this really provides for you, as you can see from the demo, is it provides a managed service. So we take care of things like the underlying Kubernetes platform and the infrastructure, things like upgrades, patching, HA of Kubernetes. So this applies to the other cloud-native services as well. We also offer an enterprise rail platform, so 5x better performance. HO indicated this, but HO also said there's a cost advantage. How much lower do you think the price is for Oracle Cloud infrastructure compared to others? Okay, it's not quite that good, but that was a great guess. We want to get there one day. A little lower, like, come on, any? That's actually really close. I'll give you that one. It's actually 19x. That is how much lower we are in price compared to the leading cloud vendor today. So Oracle also offers, as we said, we are committed to being open. We're committed to working with startups as well as large companies to make sure that we provide access to the technologies to make sure you're successful with cloud native. So we offer the cloud native services, the team I belong to in the public cloud. There's also the cloud native environment for hybrid cloud and other cloud environments that you want to use. And these are interoperable. You might have seen this from Oracle. If you haven't, we announced just yesterday what is called the service broker for the Container Engine for Kubernetes. So I just want to call this out. So this was a special announcement. And what you do when you want to deploy containers and microservices is you want to have the ability for these microservices to use things like database, autonomous transaction processing, autonomous data warehouse, object storage, and so on. And we are providing the adapters for these services through the OCI Service Broker. It's an implementation of the open source standard for Service Broker, Open Service Broker standard. And be sure to check that out. There's the bit.ly URL over there if you want more information. So we offer a free trial. So the URL is over here and the QR code as well. Please do sign up if you are interested. You can also learn more about Oracle Cloud, including signing up for the limited availability services. Oracle.com/cloud-native is that URL. So thank you so much for staying for this presentation. And do come and ask us if you have any Q&As. Thanks.